Hello, in this lecture we'll find out the area of trapezoid ABCD. In the drawing we have trapezoid ABCD, and we have here a circle that is inscribed by this trapezoid ABCD. In addition, you know that this is side AB is equal to X. This is side DC of the trapezoid ABCD is equal to 7 over X. This is angle BAD is equal to 90 degrees, and this is angle ADC. It also equals to 90 degrees inside. Again, our mission is to find out the area of this trapezoid ABCD. So, first of all, what is the trapezoid? Trapezoid is a quadrilateral with one pair of parallel sides. So here we have trapezoid ABCD. So this trapezoid is a quadrilateral. This is quadrilateral ABCD with one pair of parallel sides. Here, side DC is parallel to the opposite side AB, and therefore this quadrilateral is defined as a trapezoid. So what is the area of trapezoid ABCD? The area of the trapezoid equals to the sum of its two bases, the parallel sides, that is to say DC and AB, they are defined as the bases. So it is the sum of the bases, that is actually DC plus AB, times the height to the base, that is edge, over 2. And the height must create 90 degrees with the two bases. Here, edge creates 90 degrees with the base DC, and the height edge also creates 90 degrees with the base AB. If again, the area of the trapezoid ABCD equals to the sum of its two bases, that is actually DC plus AB, times the height, that is edge, over 2. And if we define side DC as A and side AB as B, then the area of trapezoid, this trapezoid ABCD equals to A plus B times edge over 2. Okay, so first of all, we will define the point of tendency of the trapezoid with this circle with letters. We define the point of tendency of tangent AB of side AB with this circle, this point E. We define the point of tendency of tangent AD or side AD with this circle, this point as F. We define the point of tendency of tangent BC or side BC of the trapezoid with this circle, this point as G. And finally, we define the point of tendency of tangent DC or side DC with this circle, this point as H. So here we can implement rule 2. I'll fit quickly on rule 2. According to rule 2, the lengths of two tangents from a common standpoint to a circle are equal. So we have in the drawing this circle, and we have, this is common external point, point P. From this common external point, point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other. That is to say, PA equals to PB. So we can actually implement rule 2 in our drawing. 1 equal in our drawing, if you focus on this common standpoint point A, from this common standpoint point A, we have two tangents to this second, tangent AF and tangent AE. And according to rule 2, they are equal to each other. That is to say, AF equals to AE. So if we define AF as Y, then AE also equals to Y, because they are equal to each other. Likewise, if you focus on this common standpoint point B, from this common standpoint point B, we have two tangents to this second. We have tangent BE and tangent BG. And according to rule 2, they are equal to each other. That is to say, BE equals to BG. So if you define the length of tangent BE as Z, then BG must be also equal to Z because they are equal to each other according to rule 2. Likewise, if you focus on this common standpoint point C, from this common standpoint point C, we have two tangents to this second, tangent CG and tangent CH. And according to rule 2, they are equal to each other. That is to say CG equals to CH. So if we define the length of tangent CG as M, then CH must be also equal to M according to rule 2. And finally, we focus on this common standpoint point D. From this common standpoint point D, we have two tangents to this second. We have tangent DH and tangent DF. And according to rule 2, they are equal to each other. That is to say, DH equals to DF. So if we define the length of tangent DH as T, then DF must be also equal to T. According to rule 2. So what is the length of side AB plus side DC? Side AB plus side DC. Side AB plus the opposite side, side DC of this trapezoid ABCD. Actually, side AB equals to Y plus Z plus side DC. Side DC equals to T plus M. So, in total, we actually found out that AB plus DC equals to Y plus Z plus T plus M. Likewise, what is the length of side AD with the opposite side, side BC? AD plus BC. AD equals to Y plus T plus BC. BC equals to Z plus M. Okay, BC equals to Z plus M. So if we actually found out that AD plus BC, AD plus BC equals to Y plus T plus Z plus M. So if we change the order of this expression, the order of the letters of this expression, instead of Y plus T plus Z plus M, we can write down that this expression equals to Y plus Z plus T plus M. It is allowable to change the orders of the letters here according to the algebraic identity that a plus b equals to b plus a. So actually found out that ab plus dc equals to y plus z plus c plus m, and ad plus bc also equals to y plus z plus t plus m. So those two expressions, they are both equal to the same further expression, and therefore they must be equal to each other. Okay? That is to say, AB plus AB plus DC must be equal to AD plus BC. And again, because of the fact that AB plus DC equals to Y plus Z plus T plus M, and AD plus BC also equals to Y plus Z plus T plus M, those two expressions must be equal to each other. That is to say, AB plus DC must be equal to AD plus BC. We define the length of this side AD as A we define the length of this side BC as B. So according to equation 1, we actually found out that AB plus DC equals to AD plus BC. AB equals to X, according to what is given as the question, plus DC. DC equals to 7 over X, according to what is given us in the question. Again, I think again AB equals to X and DC equals to 7 over X. And it is equals to AD. AD equals to A according to our definition, plus BC. BC equals to B according to our definition. So in total we found out that according to equation 1, X plus 7 over X equals to A plus B. Repeat again, according to equation 1, we found out actually that X plus 7 over X equals to A plus B. In the next step, we will do a construction. That is to say, from point B, we will draw perpendicular on DC. Again, from point B, we will draw perpendicular on DC. So actually, this angle equals to 90 degrees. And this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DC, this point, as point S. So actually, by doing this construction, we can deduct quadrilateral ABDS. Inside this quadrilateral ABDS, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside quadrilateral ABSD, inside this quadrilateral to 360 degrees, this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral ABSD we have 4 right angles. And we know that any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to this quadrilateral ABSD with 4 right angles as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABSD, side AB must be equal to the opposite side DS. But AB equals to X, according to what is given in the equation. Therefore, DS must be also equal to X, because they are equal to each other. Likewise, according to the sum rule, in the same rectangle ABSD, side AD must be equal to the opposite side BM. But AB equals to A, according to our definition, therefore BS must be also equal to A because they are equal to each other. And what is the length of this side SC? And again, what is the length of this line segment SC? From the drawing it is very easy to see that SC equals to DC minus DS. Again, SC equals to DC minus DS. So I write it down. SC equals to DC minus DS. So SC equals to DC. DC is 7 over X according to what is given as the question. Minus DS. DS is X. So in total, SC equals to 7 over X minus X. Okay. So actually, by doing this construction, we created here the right triangle BSC. I repeat again. By doing this construction, we created here the right green triangle BSC. So I copy this right green triangle BSC in a new page and we'll implement the Pythagoras theorem on this right green triangle BSC. Here by PT is the abbreviation for Pythagoras theorem. We have already found out that side BS of the green right triangle BSC equals to A. We just right now found out that side SC equals to 7 over X minus X. And the hypotenuse BC equals to B. So actually, this is the right triangle BSC that I copied from the original drawing. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle BSC is BC, and therefore the square of the hypotenuse is BC square, and it must be equal to BS square minus SC square. So this is equation 2. According to equation 2, we can find out that BC square equals to BS square minus SC square. BC is A, therefore BC square is A square, and it is equals to if BC is B, BC is the hypotenuse, and therefore it is B, therefore BC square is B square. And it is equals to BS square. BS is A, therefore BS square is A square minus SC square. SC is 7 over X minus X, therefore SC square is 7 over X minus X square. So according to equation 2, B square equals to A square minus 7 over X or minus X square. Here we have the algebraic identity that A minus B square equals to A plus B square minus 4 times A times B we use this algebraic identity for this expression, the expression 7x minus x squared. And we get that according to this equation, equation 2, B squared equals to A squared. And here we have minus 7, it's actually plus 7 over x minus x squared. So B squared equals to A squared, and we have here plus 7 over x minus x squared. And 7 over x minus x squared according to this algebraic identity. If we just substitute A by 7 over x and B by x, we get that 7 over x minus x squared according to this algebraic identity, it will be equal to 7 over x plus x squared minus 4 times 7 over x times x. So actually found out that according to equation 2, B squared equals to A squared plus 7 over x plus x squared, and here we have x in the numerator and x in the denominator, so x will get cancelled, and we left only with minus 4 times 7, that is minus 28. So in this equation 2, we have the expression of 7 over x plus x squared. We have this expression, and we have already found out that according to equation 1, this is equation 2, we have already found out that according to equation 1, this expression 7 over x plus x, 7 over x plus x equals to A plus B. So we substitute 7 over x plus x, this expression here, by a plus b, because it is equals to a plus b according to this equation, equation 1. And we get that according to this equation, equation 2, b squared equals to a squared plus 7 over x plus x is a plus b according to this equation, equation 1. If 7 over x plus x is a plus b, it means that 7 over x plus x squared will be equal to a plus b squared. So we actually found out that according to equation 2, b squared equals to a squared plus a plus b squared. Here we'll open the brackets on this side of this equation, equation 2, and again that according to this equation, equation 2, we have in this side of the equation b squared is equals to a squared plus a plus b squared equals to a squared plus b squared plus 2 times ab. So here we have b squared on both sides of the equation, so b squared will get cancelled. So in this side of the equation we left with nothing, that is to say 0, equals to the other side of the equation we have a squared plus a squared, that is 2a squared plus 2ab. Actually here, according to equation 2, we actually found out that b squared equals to a squared plus 7 over x plus x minus 28. So I forgot to write minus 48 in this equation, equation 2. So I will add minus 48 to this equation, equation 2. Here we have also minus 28. And therefore, according to equation 2, I actually found out that 0 equals to 2a squared plus 2ab minus 28. So here we have to this equation, equation 2, 28. And we get that according to this equation, equation 2, here 0 plus 28 is 28. That equals to 2a squared plus 2ab. Here we divide this equation, equation 2 by 2. And finally we get that according to this equation, equation 2, a squared over 2 is a squared plus 2ab over 2 is ab, and it is equals to 28 over 2 is 14. So actually according to equation 2, we found out that a squared plus ab equals to 14. This is according to equation 2. Well, according to equation 1, we already found out that x plus 7 over x equals to a plus b. So, what is the area of trapezoid ABCD? We know that according to what I already explained in the beginning of the lecture, the area of the trapezoid equals to the sum of its two bases times the height over 2. And the two bases must be parallel to each other. So here we know that quadrilateral ABSD this is a rectangle, and we know that the opposite sides of a rectangle are parallel to each other. That is to say, side AB is parallel to the opposite side DS. but DS is part of the straight line DC. Again, DS here, DS is part of the straight line DC and is parallel to AB. So if part of a straight line is parallel to another straight line, then the straight line DC itself must be also parallel to AB. Again, DC must be also parallel to AB. Therefore, the two parallel sides in trapezoid ABCD are AB and DC. And the sum of the two opposite sides is AB plus DC. So the area of trapezoid ABCD equals to the sum of its two bases, that is actually AB plus DC times the height. So what is the height in this trapezoid ABCD? The height must create 90 degrees with the two bases. And here you can see that AD creates 90 degrees with the base AB, and AD also creates 90 degrees with the base DC, and therefore AD is the base. So the height is AD divided by 2. So in conclusion, we should found out that the area of trapezoid ABCD equals to the sum of its two bases, that is actually AB plus DC, times the height, that is AD, over 2. AB equals to X plus, so it is AB plus DC. DC equals to 7 over X according to what is given as the question. So DC is 7 over X times the height AD. AD equals to A according to our definition, or divided by 2. So actually found out that the area of trapezoid ABCD equals to X plus 7 over X times A over 2. But we have already found out that X plus 7 over X according to this equation 1 equals to A plus B. So we can substitute X plus 7 over X by A plus B. We'll do it now. X plus 7 over X according to this equation 1 is A plus B times A over 2. Here we'll open the brackets of this expression and we get that A times A is A squared plus A times B is AB divided by 2. In conclusion, I should have found out that the area of trapezoid ABCD equals to A squared plus AB over 2. But we have already found out that according to this equation 2, A squared plus AB equals to 14. Therefore, we can substitute A squared plus AB in this expression by 14. We'll do it now, and we get that A squared plus AB is 14 divided by 2. 14 over 2 is 7. In conclusion, we actually found out that the area of trapezoid ABCD equals to 7 square units. And that is the answer to the question. I repeat again. The area of this trapezoid ABCD equals to 7 square units. In the next step, I will summarize the lecture. In this lecture, we found out the area of this trapezoid, trapezoid ABCD. So, in the drawing, we have a circle that is inscribed by this trapezoid ABCD. In addition, we know that side AB of this trapezoid ABCD equals to x, and the opposite side DC equals to 7 over x. This is angle BAD, that is a right angle. This is angle ADC, that is also a right angle. Again, our mission is to find out the area of this trapezoid, trapezoid ABCD. Okay, so first of all, what is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. Okay, again, trapezoid is a quadrilateral with one pair of parallel sides. Here we have, this is trapezoid ABCD, and you can see that this trapezoid ABCD, it is actually a quadrilateral, and because of the fact that side DC is parallel to side AB, this quadrilateral is defined as a trapezoid. Again, here side DC is parallel to the opposite side AB, and therefore this quadrilateral ABCD is defined as a trapezoid. And the area of this trapezoid equals to the sum of its two bases, and the bases are defined as the parallel sides, that is to say DC and AB. DC equals to A, AB equals to B, and therefore the sum of the two parallel sides is equal to A plus B times the height. The height is h over 2, so the area of trapezoid ABCD equals to A plus B times h over 2. The height h must create 90 degrees with the two bases. You can see here that h creates 90 degrees with the base DC, and it creates also 90 degrees with the base AB. And therefore the height is h. And again, the area of the trapezoid ABCD equals to A plus B times h over 2. Okay, so first of all, we defined the point of tangencies of this trapezoid with this circle with letters. We define the point of tendency of tangent AB with this circle, this point as point E. We define the point of tendency of tangent AD with this circle, this point as F. We define the point of tendency of tangent AC with this circle as G, this point. And finally, we define the point of tendency of tangent DC with this circle, this point as H. So here we can implement rule 2. According to rule 2, the lengths of two tangents from a common external point to a circle are equal. So in the drawing we have a circle, this is common external point, point P. From this common external point, point P, we have two tangents to this circle, tangent PA and tangent PB. And according to rule 2, they are equal to each other. That is to say, PA equals to PB. Okay? We can implement rule 2 in our drawing. Why? Because in our drawing, if we focus on this common external point, point A, from this common external point, point A, we have two tangents to this circle, tangent AE and tangent AF. And whenever you have, for a common external point to a circle, two tangents to the circle, like in this drawing, they are equal to each other according to rule 2. That is to say, AE equals to AF. So if we define the length of tangent AE as y, then the length of tangent AF must be also equal to y, because they are equal to each other according to rule 2. Likewise, if you focus on this common external point, point P, from this common external point, point B, we have two tangents to this circle, tangent BE and tangent BG. And according to rule 2, they are equal to each other. That is to say, BE equals to BG. Again, BE equals to BG according to rule 2. So if we define the length of tangent BE as Z, then the length of this tangent BG must be also equal to Z because they are equal to each other. Likewise, if we focus on this common external point, point C, from this common external point, point C, we have two tangents to this circle. We have tangent CH and tangent CG. And according to rule 2, they are equal to each other. That is to say, CH equals to CG. So if we define the length of tangent CG as M, then the length of this tangent CH must be also equal to M, because they are equal to each other according to rule 2. And finally, if we focus on this common standpoint point D, from this common standpoint point D, we have two tangents to this circle. We have tangent DH and tangent DF. And according to rule 2, they are equal to each other. That is to say, DH equals to DF. So if we define the length of this tangent DF as T, then the length of tangent DH must be also equal to T, because they are equal to each other. In the next step, we added side AB to the opposite side DC. Again, AB plus DC. Here, we added side AB to side DC in the trapezoid ABCD. So AB equals to Y plus Z, and DC equals to T plus M. Therefore, in total, AB plus DC equals to Y plus Z plus T plus M. Okay, likewise, we added side AD to the opposite side, side BC, in this trapezoid ABCD. Again, AD plus BC. So, what is the value of AD plus BC? AD equals to Y plus T, and BC equals to Z plus M. So, in total, AD plus BC equals to Y plus T plus Z plus M. So here we can change the orders of the letters in this expression according to the algebraic identity that A plus B equals to B plus A. So instead of Y plus T plus Z plus M, we can write down Y plus Z plus T plus M. We just change the orders of the letters here, and those two expressions must be equal to each other, again according to the algebraic identity that A plus B equals to B plus A. So in conclusion, we actually found out that AD plus BC equals to Y plus Z plus T plus M, and AB plus DC also equals to Y plus Z plus T plus M. So those two expressions, that is to say AB plus DC and AD plus BC, they are both equal to the same third expression, that is Y plus Z plus T plus M, and therefore they must be equal to each other. That is to say AB plus DC equals to AD plus BC. Again, AB plus DC equals to AD plus BC. Again, those two expressions are equal to each other. So according to equation 1, we actually found out that AB plus DC equals to AD plus BC. In the next step, we define the length of this side AD as A, and we define the length of this side BC as B. So I actually found out that AB equals to X, and DC equals to 7 over X according to what is given as the question. I'll repeat again. Here AB equals to X, and DC equals to 7 over X according to what is given as the question, and it is equals to AD. AD is A, and BC is B. So in total, again, AD is A and BC is B. So in conclusion, actually found out that according to equation 1, AB plus DC equals to AD plus BC, and it is equals to, it means that X plus 7 over X equals to A plus B. This is according to equation 1. In the next step, we did a construction. That is to say, from point B, we draw perpendicular on DC. Again, from point B, we draw perpendicular on DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B inside DC as point S. By doing this construction, we get the quadrilateral ABSD. This is the quadrilateral ABSD that we created by doing this construction. So inside this quadrilateral ABSD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle. In total, the sum of those four angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside this quadrilateral ABSD to 360 degrees, this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral ABSD we have 4 right angles, and we know that any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to this quadrilateral ABSD that has 4 right angles as a rectangle. But we also note that the opposite sides of a rectangle are equal to each other. So in rectangle ABSD, side AB must be equal to the opposite side DS. But AB equals to x, therefore DS must be also equal to x. AB equals to x according to what is given as the question. So AB equals to x, therefore the opposite side DS must be also equal to x. Here DS equals to x. Likewise, according to the same rule in the same rectangle ABSD, side AD must be equal to the opposite side BS. But AD equals to A, therefore BS must be also equal to A, because they are equal to each other. Okay, and what is the length of this line segment? Line segment SC. From the drawing, it is very easy to see that SC equals to DC minus DS. Again, SC equals to DC minus DS. Again, SC equals to DC minus DS. So SC equals to DC. DC is 7 over x, according to what is given in the question. And DS, we just right now found out that DS equals to x. So in total, SC equals to 7 over x minus x. Again, SC equals to 7 over x minus x. So in the next step, I copied this right green triangle BSC in a new page, and we implemented the Pythagoras theorem on this right green triangle BSC. So actually, this is the right triangle BSC that I copied from the original drawing. Here by PT is the version for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the slopes of the perpendiculars. In this right triangle BSC, it means that BC square equals to BS square plus SC square. Again, BC square equals to BS square plus SC square. BC, the hypotenuse BC is B, therefore BC square is B square, and it is equal to BS square. BS is A, therefore BS square is A square plus SC square. SC is 7 over x minus x, therefore SC square is 7 over x minus x square. So according to equation 2, we actually found out that B square equals to A square plus 7 over x minus x square. So here we use the algebraic identity that states that A minus B square equals to A plus B square minus 4 times AB. We use this algebraic identity for the value of this expression, 7 over x minus x squared. And actually, according to equation 2, we found out that b squared equals to a squared plus, we have here 7 over x minus x squared. According to this algebraic identity, that a minus b squared equals to a plus b squared minus 4 times ab, we will get that 7 minus x over x squared. If we just substitute a by 7 over x and b by x, we get that 7 over x minus x squared equals to 7 over x plus x squared minus 4 times 7 over x times x. So here we have x in the denominator and x in the denominator, so x will get cancelled. And here we left only with minus 4 times 7, that is minus 28. So according to equation 2, we shall find out that b squared equals to a squared plus 7 over x plus x squared minus 28. But we have already found out that 7 over x plus x equals to a plus b according to equation 1. So we can substitute 7 over x plus x in this again expression by a plus b. But if 7 over x plus x equals to a plus b, it means that 7 over x plus x squared must be equal to a plus b squared. So in total, according to equation 2, we actually found out that b square equals to a square plus a plus b square minus 28. Here we open the brackets on this side of this equation and finally found out that b square equals to a square and a plus b square equals to a square plus b square plus 2 times ab minus 28, of course. Minus 28 from here. So here we have b square on both sides of the equation, so b square we get cancelled. And here we left with nothing, that is to say 0. In the other side of the equation we have a square plus a square, that is 2a square, plus 2ab minus 28. Is equals to 0. Here we added 28 to this equation, equation 2, and finally found out that according to this equation, equation 2, 0 plus 28 is 28, and it is equals to 2a square plus 2ab. So here we divided this equation, equation 2 by 2. Finally found out that here we have here we have 28 equals to a square plus a square is 2a square, and here we have plus 2ab, that equals to 28. So here, according to equation 2, we should find out that 28 equals to 2a square plus 2 times ab. Here we divided this equation, equation 2 by 2, and finally found out that 2a square over 2 is a square, and 2a times ab over 2 is ab, and it equals to 28 over 2 is 14. So according to equation 2, we actually found out that a square plus ab equals to 14, while according to equation 1, we have only found out that x plus 7 over x equals to a plus b. Okay, so we have here two equations, and what is the area of trapezoid ABCD? The area of this trapezoid ABCD, according to the formula that I presented to you in the beginning of the lecture, the area of this trapezoid ABCD must be equal to the sum of its two bases times the edge times the height over 2. Again, the area of this trapezoid ABCD equals to the sum of its two bases times the height over 2. And here, the two bases are the two parallel sides in the trapezoid. Here, side AB is parallel to side DC. Why side AB is parallel to side DC? Because of the fact that ABDS is a quadrilateral, and this quadrilateral is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So in rectangle ABSD, side AB is parallel to side DS. But DS is part of the straight line DC. Again, DS is part of the straight line DC and is parallel to AB. And if a part of a straight line is parallel to another straight line, then the straight line itself DC must be also parallel to the other side, to the other straight line, that is AB. In conclusion, we found out that DC is parallel to AB, and therefore the two bases are the two parallel sides, that is AB and DC. So the sum of the two parallel sides, that are the two bases, is AB plus DC. Again, the area of the trapezoid ABCD equals to the sum of its two bases, that are AB plus DC, times the height. The height must create 90 degrees with the two bases. Here, side AD creates 90 degrees with the base AB, and this is side AD, that is also creates 90 degrees with the other base, that is DC. This again equals to 90 degrees, and therefore the height is AD. Okay, the height is AD, so it is times the height, that is AD over 2. So in conclusion, I actually found out that the area of trapezoid ABCD equals to the sum of its two bases, that are AB plus DC, times the height, that is AD over 2. according to what is given as the equation, AB equals to x and DC equals to 7 over x. Again, AB equals to x and DC equals to 7 over x. And the height AD equals to A according to our definition. Again, the height AD equals to A according to our definition. Therefore, we substitute AD by A divided by 2. So in conclusion, we actually found out that the area of trapezoid ABCD equals to x plus 7 over x times A over 2. But we already found out that according to equation 1, x plus 7 over x equals to a plus b. Again, x plus 7 over x equals to a plus b. Therefore, we can substitute x plus 7 over x in this expression by a plus b. We did it, and we actually found out that x plus 7 over x is a plus b times a over 2. So here we open the brackets of this expression and found out actually that a times a is a squared plus ab over 2. So, in conclusion, actually found out that the area of trapezoid ABCD equals to a squared plus ab over 2. But we already found out that a squared plus ab, according to this equation 2, equals to 14. Therefore, we can substitute a squared plus ab in this expression by 14. We did it. So, a squared plus ab is 14. This expression equals in total to 14 over 2, that is 7. In conclusion, we found out that the area of this trapezoid ABCD equals to 7 square units. Okay, thank you very much.